Hello guys, it's me Isaac, and today we're going to talk about ANOVA, which stands for Analysis of Variance. Okay? Let me start with the specific two data set. And we have 9 numbers here. And first situation, let me just pull. Okay, so first situation here, we have 9 numbers, but as you can see, we have 3 numbers, three numbers which is white, whose color is white, and then 4, 5, 6 we got red numbers, and for 7, 8, 9 we got blue. And this means that these 3 came from the same group. So let's say maybe all these 9 numbers is the homework score. Okay, so homework score out of 10, and these 3 came from class 1. And the red numbers indicates that these 3 came from the class 2. And these 3 for the blue numbers, I'd say this one is the homework score from of the students who came who belongs to the class 3. Okay, so this is the situation 1, and we have the same situation, but when you look at these numbers more closely, it is has a little bit difference between the situation 1. So we have 9 numbers, 1, 2, 3, 4, from 1 to 9. However, we can see we have 1, 5, 9 for white, which means I would say these 3 came from class 1. And we have 2, 4, 7. These are red numbers, which means these are class 2, right? And 3, 6, 8. These are blue numbers, which means they came from class 3. Okay, so I think everyone get the situation. Okay, and what I want to test is that I want to compare the mean of each group. So in my hypothesis, in my null hypothesis, is that mu of the group white, which is class 1, so average homework score of the class 1, 2, 3 are the same. So that's my null hypothesis. Okay, and since we have 2 situations, which data set can be which data set you can say the average of the homework score for each groups are the same, if you want to choose between these 2. Okay, so let me see. So this is the group 1, class 1, so whose sample mean is actually 2, right? This is mu1. I don't want to say mu1 because it's not mu1, because this is the sample. So let's say this one is x1 bar. Okay, and this is the second class 2, so I'd say this one sample mean for this class 2 is a 5, and also I can say this is sample mean for class 3, which is 8. Okay, and let's say this one, I'd say x1 bar is the 1 plus 5 plus 9 divided by 3, so 6, I get 5 for x1. Okay, and x2 bar is the sample mean from the of the data which came from the class 2. So this one, this one, this one. So I want to calculate the summation of these three numbers, 2, 4, 7, and divide by 3. And I would get 6 plus 7, so 13 divide 3. So I'd say this is like 4 point something. Okay. How about x3 bar? x3 bar is the sample mean of the data came from class 3, so these 3, right? So 3 plus 6 plus 8 divided by 3, and then this is 17, so let's say these are 5.5 something. Okay, so for situation 1, we have x1 bar is 2, x2 bar is 5, x3 bar is 8. However, for situation for the second situation, we have 5 for the x1 bar, 4.3 for the x2 bar, and 5.5 for x3 bar. So compared to the situation 1 and situation 2, I would say situation 2 is the more has more chance to this how can I say, when we see this situation 2, I would say, oh, I guess mu1 and mu2 is a mu3 are all the same, because the sample mean for each groups are very similar. But however, when I get the situation 1, like 2 for the sample mean for group 1 and 5 for the sample mean to group 2 and 8 for the sample mean for group 3, I wouldn't say these are the same. Right? Because we can see that clearly, like group 1 is related to the more lower number, and group 3 are related to the numbers relatively higher than the others, right? So if we can say, if we can find some measure, I'd say I'd call my measure as f. If I can find some measure that for situation 1, this measure maybe tends to get a higher number, and for situation 2, if this measure tends to have a lower number, then I can use this f to my statistic. Okay, and for the ANOVA, we said that this one is analysis of variance, and this variance is closely related to the standard deviation, right, or spreadness of the distribution. Let's see. So let me just write it down. So we have x1 bar is 5, x2 bar was 4.3, x3 bar five. So some of you might think that, oh, definitely situation 1, we can say that they are different, totally different group. Why? When you think that way, actually in your brain, you are comparing the two types of variance. Okay? First, you are considering variance of the sample mean. Okay? So variance of the sample mean is like the sample mean varies from 2 to 8, right? Per each group. Okay? And also you are comparing the variance of the each groups. Okay? So what I'm saying is each group spread like this, right? So when you think about the mean for each group, within the group, the data spread like this much, right? But when you look at the sample mean for each group, they are spread like this. So since this, how can I say this? I would use the black. So black bar represent the variance of the sample group means, okay? And yellow here, yellow bar is the sample variance of the within the group, like the variance of the data's within the group. Okay, so compared to the black bar and the average of the yellow bar, black bar is much larger in situation 1, right? How about here? So since this is the data belongs to class 1 and these two, so this is the variance within the group, right? So in group 1, the data spread like this, right? And when we think about the group 2, which is 2, 4, 7, I'd say this yellow bar is the spreadness of the group 2, right? And when we think about the group 3, which is 3, 6, 8, these yellow bar represent the spreadness of the group 3. Okay, so we have like larger yellow bar here, and let me just change the color for representing the within the group. Representing the variance of the group sample mean. So we have group sample mean is 5, right? So 5 is here, and group sample mean 2 and 3s are 4.3 and 5.5. So this black bar represents the erase this. Okay. So in here we have black bar, which represent the variance of the group sample mean. So we have much larger yellow bar here, right? So we have different situation in 1 and 2, and we are comparing the length of the yellow bar and the black bar. In this situation 1, we have larger black bar, and in situation 2, we have larger yellow bar. And this F statistics using the ratio of these yellow and black bar. So in what is that? In a numerator, we are using average of So let me see. Let me check. Yep. So, numerator is related to the black bar, black line variation, or length. I would say length related to black bar, length, and yellow bar goes to the denominator. Okay, so if this f is large, which means black bar length of the black bar is much larger than the average of the yellow bar. I mean, some of you may ask that why do we use average here? Because we have one black bar and the yellow bar has a 3, right? I mean number of groups. Like, since we have 3 groups, we have 3 yellow bar and 1 black bar, so it's not fair. So that's why we are using the average of the yellow bar length here. I'd say. Okay. So when we have large f, which means we have much larger black bar than the average of the length of the yellow bar, I would say, oh, they came from different group. Okay. And when we have a situation where like average yellow bar is much larger than the length of the black bar, then I would say, oh, they came from the same group, which means each population has the same mean. Okay, that's the idea of the ANOVA. And I'd say that F statistic, since they are using the this form, like this, the variance of the group sample mean is the numerator, and the variance of the individual in the same group is a denominator. The F identified by 2 factors. One is the number of groups we have. So in our situation, we have 3 groups, right? And we just using the I minus 1, so we have like 3 minus 1, and this one, n minus 1, is like a total observation we have. So we had 9 numbers as our observation, and minus subtracted by number of the subgroups, the number of groups. So we had 3 groups, so this is like 6 and 2. And why do we use this 2 and 6? Because when we are talking about the normal distribution, we always talking about the mean and the standard deviation, right? And this one, F, also follows some specific distribution, which can be specified by these 2 numbers, 2 and 6. So you can just think this I minus 1 and n minus I as a parameter of the F statistics or F distribution. Okay? So in our courses, actually, we don't need to know how do we calculate the F statistics, because we are using the SAS to calculate that. So I'm gonna skip this actually calculation, but at least you should understand why we are using F statistic. Okay, but some of you may be interested in how do we calculate the F. I will just show you the sample calculation for our 9 numbers. Okay, so you can calculate the 27, and these are related to the black bar. And MSE, these are related to the average of yellow bar. Okay, so maybe you can just look into it, because all the numbers are really simple. So since we have 27 and 1, our F statistics will be 27. Okay, so now we are understanding why do we use the F statistics for the testing of the null hypothesis, like all the population mean from the each groups are the same. And now I wanna give you the situation where we are safe to apply the ANOVA. Okay, so in ANOVA, we are assuming that population follows the normal distribution, and this is the key part. We are assuming that the older population has the same standard deviation. Okay, and we are also assuming that each sample came from the independent simple random sample. So these are assumptions, and in practice, we are usually checking the two factors. One, do we have large enough sample observation? If we have large enough sample observation, then by the central limit theorem, we are kind of safe that our distribution follows the normal distribution. And also, to check the same standard deviation for each mean, we usually check this thing. So in our case, we have 3 groups, right? So for each group, we're gonna calculate the sample standard deviation for each group. So we'll get S1, S2, S3, which is the sample standard deviation for group 1, and which is the sample standard deviation group 2, and S3 indicates the sample standard deviation for group 3. Okay, and we can say we can determine which one is the largest one and the smallest one. And if among them, if the largest sample standard deviation for a specific group is less than 2 times of the smallest standard deviation for the group, then we are safe to use ANOVA. Okay, so I'm gonna end here, and I'm gonna explain how do we calculate the ANOVA, how do we test, how we do the test, ANOVA test in SAS. Okay, let's do some programming in SAS. So in my website or our professor's website, if you go to the website and then find the hot dog data, so hot dogs DAT, if you click that, you can see these data set. Okay, and basically this hot dog data set contains the data on sodium and calories contained in each of 54 major corn dog brands. Okay, and we have 2 columns, 3 columns actually. So let's just so first column we have beef, meat, and poultry, and these are types of corn dog. And the first column related to the calories per corn dog, and the third column related to the sodium per amount of the sodium in the corn dog. Okay, so let's just load the data in SAS. So let me just copy this and then paste. In the SAS system, and if you look at these code, we are actually using this same structure of the code for loading the data. First, line is we are just grabbing the data set from this URL to the sets, right? So we are naming that URL as my data, and then in here we actually grab it, right? And then I declare I set my name of the data set as condog, and I just put some column names here. I named it for the first column as a type, and I let our SAS knows that the types of the variable is the character variable by putting this $sign. And the second column and third column name we set as calories and the sodium. Okay, so if you submit this, you can see there is no error in the SAS program. So let me just using print procedure to see that my data is in the system. Okay, so let me just run this code. Then now I can see all the data in the hotdog DAT file. It's in my SAS system. Okay, and let's just go to our website. Okay, so after we load the data, we want to just see what's going on in the data set. Okay, so our interested variable is the calories, so we are just using the calories, but you guys can do the same procedure using the sodium. Okay, sodium variable. So by using let me just read again. Copy this, or I'll just copy all of them, and then here, paste here. So if I submit this one, it will show, and then run. Just don't forget, run that. So run it. Then I will get some descriptive statistics and graphs related to the calories by groups. Okay, so so we have 17 observation for poultry type. Okay? So we have 17 for meat type, and also 20 observation for beef type. Okay? And then we can actually check the mean of each group, and also last part, we can see the box plot by groups. And as we can see, this one related to the beef type, and the middle one is related to the meat type, and the third one is poultry. However, we can see that these are kind of disputed, like same, but this one is a little bit different than this, right? And we want to see our F statistics, which is the statistic used in the ANOVA, can capture these difference. Okay, and the second one, if you're using the if you are use univariate, you will get a lot of information, but sometimes we want to just see the more compact information. So if you're using the means procedure, it will give you the means for each group. So we have 20 observation, and its mean of the calories is 156 for the beef group, and for meat we have 158, and number of the observation we had in that group was 17, and we have same number for the observation, 17 observation in poultry group, and its mean is 118. So we have a kind of sense that this group has a different characteristics than these two based on the only mean. Okay, and also we can check like standard deviation for each group is a 22 and 25 and 22, which means we are kind of safe to use the ANOVA based on the standard deviation for each group. Okay, and for ANOVA test, what we can do is this. Okay, so this last part is actually the option. So if you want to do the ANOVA only, then this is the code you can go with it. So proc ANOVA will give you the ANOVA test result, and we are we set that type variable is related to the class, right? So ANOVA, we should set which variable is related to the SAS so that the SAS can calculate the means for each group by using this type variable. Okay, and we can set what is that? We can say that this calories is our interested in variable, and we want to get the means for each type. Okay, so if you submit this one, then we'll get this result, and we can find the F statistics in here, 16.07, and corresponding p-value is way less than 0.001, which means one of these, at least one of this group means, population group means, is different from the others. Okay, and also we can check the F statistic in here. However, using this ANOVA, we cannot say which group is different than others. Okay, so based on the F group we got here, we can say, oh, one of them, at least one of them is different than others, but we cannot say which one is different than that. So we want to put this Pomperoni alpha is 0.05 to check the which group is different than the others. Okay, so once you submit this one, we'll get another result, and in here, beef and meat and beef type oh, so I'd say this one. So meat minus beef, the confidence interval includes the 0. However, meat and poultry, meat minus poultry, there are 95 confidence interval does not include the 0, right? So we can say that, oh, they are actually different. So when you see this 3-star, they are indicating that they are significantly different from the 0, and we are considering the difference between the sample mean. I mean, difference between the means of the group here. So these 4 are significantly different from the 0. However, these are not the 4. Actually, these 4 means there are 2 groups, 2 bridge that are different than the 0, because we have same object here. Meat minus poultry is actually same as the poultry minus meat, right? So these and this are actually the same group comparison, and the beef minus poultry and the poultry minus beef is actually the same thing. So what this ANOVA procedure, Bonferroni option said that poultry is different than the meat, and poultry is different than the beef, right? And also we can check the same fact from the box plot. Actually, poultry is different than the beef group, and the mean of the poultry is different than the meat group. Okay. All right. I think this is for all today. Hope you guys enjoy the weekend. Thank you.